So, since these current class and the previous class and also next classes will be a little bit like advanced in Python programming, I hope you people come with either laptop, either the notebook, or else it will be a little bit like difficult to understand. So let us see, and any questions like so far, whatever the topics we covered, is if anybody has any questions, please ask now, because I feel that like some of you not asking any question, even though they have a doubt or not able to understand. So it will be very difficult later on to understand if you are not asking those questions. So let us start with where we left in the last class. So we covered in the last class, what all things we covered is actually we started about functions. In the functions, we covered how to write a simple function, and we also covered little bit like detailed about calling the function, different kind of ways of passing the parameters, and different ways of arguments, default arguments, unlimited arguments, and all those things we discussed in the class. And also we discussed about local scope and global scope. So global scope, so that we discussed actually in last class. So if anybody has any question on the local scope and global scope, local and global scope, let me know, because I felt that actually some of you not able to understand that, but if you understood it actually, then we will continue from where we left. So any questions on local scope and global scope? What I was discussing about variable scope. So variable scope means till what extent that variable will be visible. So means like we can visible means like we can access this, we can edit it actually. So if it is local to some function, then that will be called local scope. If it is global, means like every other function or inside of the function, outside of the function you can access, then that is called global scope. So depending on which location, means like till what location it is available. So if you see this diagram, so if that variable is only visible within the function, then local namespace actually. So if it is global namespace, means like this model means like when a file or in a package. So you have not understood what is a package, but right now you assume that module means like is one file. So one file, whatever you are writing. So if that visible in the entire file, so that variable is accessible in entire file, you can access and edit actually. That is a global square. And built-in namespace means actually built-in function. Built-in functions are always available. No need to call, like length, type, ID, all those things. What we regularly use, no, those are the built-in functions. So built-in functions are accessible anywhere. So no need to, means like they are visible. So they'll be visible in this file. It will be visible in another file. It will be visible in another package. So they are of what is called built-in namespace or built-in scope. It's like it's universal, it's like they'll be available everywhere. So what we were discussing is mainly about the function within the function and the model scope. So this is what we discussed actually in the last class. So any questions here? Okay. So let us start with the next topic, that is a recursive function. So how many of you know what is meant by recursive function? Anybody heard about the recursive function? Okay. See, let me reiterate again. So whenever I say that like one function, so how the function will be, so for example, this is a function and I'll be defining this function. So I'll be defining this function. So using def and name and arguments and colon and something like this is what number of statements actually. Then finally it will be return. So this is how the function. So then this is how I'm trying to call this function outside. I'm trying this calling this function. So I'm calling this function. So this is a normal kind of function. Yes, correct. So this is normal call, means like I am calling this function outside, from outside of that function, I'm calling this function. So this is a normal function call. But from within the function, like so if I have another call here, so I'm calling this function again and again, this function from within that function that is called recursive function. It's like, see, whenever we define a function, somebody has to call. So you will be calling that function from outside the function, some other place actually from another function or whatever it may be. Outside the function, that is a normal function call. And if you are calling, if that function is called by its within its function, means recursively itself actually, then that is called a recursive function. So recursive function, one thing you should be knowing actually, like when that whenever certain functions are called again, so we know that like there is exit function. Like for example, initial case, no, so I said this is a function and this is a return. So whenever we call a function, so from outside, so it will call this function and it will start executing, and when there is a return, it will come out. But if it is a recursive function, so if it is a recursive function, it is calling here. So sometimes it has to call itself. So and sometimes it has to exit. So this is very important, because if it is not exiting, then it will become infinite kind of a recursive call. So infinite means like it's keep on calling. It never ends actually. It's like, so how it happens actually, like so same thing that like def I say our function is a recursive function, and in that like I have multiple statements, like one statement, two statement, three statements, and there are here I'm calling this function, and here I'm returning. So something that like. So now initially like I will be calling this function from outside. So I have called this function, and within this function again I am calling. So again I'm calling. So it's like again I'm calling. How many times? Like sometimes you have to exit from this, or else like it will be infinite loop. It's like it will keep on working on that. So that is not possible. So in recursive function, one thing you should be remembering is actually there should be entry point and there should be an exit point. So what should be the entry point and what should be exit point? So so the recursive call, if there is no exit point, if there is no exit point, then it will be very, very difficult. So let us discuss writing on a simple recursive function. So let us write a simple recursive function. So this is a function. So this is a function is written in a recursive fashion. So what is that actually? So now I am trying to define something like a factorial. Why I have selected factorial? Factorial is by default, it is a recursive nature. Why it is a recursive nature? So whenever I'm trying to calculate a factorial of a R, so how I will be calculating? So first I will be doing R into R minus 1, then into R minus 2. So like that up to 1. So by this nature, seems like, so by nature itself, it is a recursive nature. Recursive is like every time I'm calling R, so with one value less than that actually. So that is the reason I'm trying to use such functions, like such any problem statement where you see there is a recursive use of the element. Recursive use of the element means like I'm recursively using this R for something, whether I'm trying to do multiplication, whether I'm trying to add, whatever it will be. So I'm using this R and keep on reducing this R. It's like some number is like repetitively used. So it's like, see, this R, this something similar. No? So such kind of functions, such kind of problems are suitable for recursive functions. So let us see how I have written a recursive function for this factorial. So this is a function name. So I said def is the definition for function, and I have given the function name, and it will take one parameter. That parameter is called x, and then the colon. This is the thing. And if you see that this thing, this is a doc string. So I just defined a doc string. Doc string is actually to understand what is this function does. So this is nothing. So this is optional thing and nothing. So now what you should be knowing is actually when, so there should be one point where it should be returning. So one point it will be returning and one point it will be calling recursively. So if you see here, actually what I'm trying to do, if x is equal to 1, means like if x is equal to 1, I am trying to return 1. Means like why we are saying x is equal to 1, I am trying to return, because finally this is 1. So if x is equal to 1, I should be returning 1. So this is something similar to that. So return 1. Else, if x is not equal to 1, so what I will be doing? So for example, initially, if r is equal to 1, r is reduced to 1, I will be returning 1. If r is not 1 actually, then what I will be doing? I will be calling r into another subfactorial with r minus 1. Because this is how, because this is how I'm trying to do. So this is how this function is there. Return x into factorial of x minus 1. Because if this minus 1 is not there, and this never terms actually, because somewhere else, whatever the condition, this is a condition for exist. This is a condition for exiting from the loop. So this is not the condition for exiting from the recursive call, because I am calling here. So this return is not the exit, because in this return I am trying to call again. So it doesn't exit. So, but this is the one, it will exit the definition. It will come out of the functions actually. So it's like, so it will be written from that function, proper written from that. Here, recursive call, it is written, but like it is a recursive call. So, but from this position to this position, to go there, somewhere else I should have some kind of a link. So if you see x is there, and here also I'm passing x actually, this x, who is reducing? Nobody is reducing. So this x doesn't lead to x is equal to 1. So somewhere else, like see, what is the two things you should be knowing? There should be one exit point has to be there, and there should be some kind of a recursive call, and that also expression to take this call to end. It's like, what is that means actually? See, if I'm trying to pass r, and somewhere else I'm not reducing r value, and this reduction doesn't lead to 1, then it is an infinite kind of a loop. So this has to be there, like one calling repetitively but reducing the value, some kind of values. So this is the key things about the recursive function. So this is a recursive function. Why I'm calling recursive function? Within the function, I'm calling this function. Within the function, I'm calling this function. So this whole thing is a recursive function for a factorial. So now what I'm trying to do, so okay, now this is what I have defined, and I'm trying to run. So this can be outside also. So it is not necessary that like it will be here only. So I will try to write here so that like you will understand. So here I have defined a recursive function. I'm trying to execute it actually, and I'm trying to execute this. So this is only definition, and here I'm running. So factorial of 3 is 6. So factorial of 4 is, so 24. Factorial of, factorial of 5 is 120. Any question here? Anybody is not understood recursive function? If you have a laptop, so you can try executing this actually. You can try executing this. So there is no, see, this can be, it can be X, it can be R, it can be anything. So name you can define. So only three statement is important. One is the exit point. Another is the function call. So you should be calling that actually repeatedly. And another one is the, there should be terms to reduce it actually, these three. So this is important, and then you'll be calling. So if you have a laptop, you can try this function. So simple function, it is very, very simple to understand. So what I will do now, I will try to paste here in text box. You try to execute it. So anybody with laptop? Are you guys trying it actually? Do you have laptop? Do you guys have laptop? Okay. Okay. Then, okay. So we'll continue then. Okay. So I hope you understood the recursive function. No. Still assume that like if it is new to you, so how to build a recursive function? So let us try to do a normal function. So first write a factorial normal function. How should I write a factorial normal function? In last class I explained def factorial of n and fact is equal to 1 for I in the range. So 1 into, then this is what we discussed here in the last class actually, like how to write a factorial function. So we have written one factorial function here actually. So we have written a factorial function here and I'm just using the same function. So this is the thing which you have written in last class. So this is not a recursive function. So I'm just passing a number and iteratively I'm trying to calculate the factorial and I'm trying to return the same function I have written. So same function is here. So so now what I have done is actually I have just written a simple function. So how to convert this? So sometimes we can convert the normal function into recursive function, but how to convert? So now what is important? It is the starting point. It is a starting point and it is a termination point. Correct? Fact is equal to 1 or fact is the thing. So what I'm trying to do, I'm converting if it is equal to 1. If it is again, I'm trying to return. And whatever I'm trying to write here. So this for loop. So this for loop is replaced by recursive function I'm trying to do. So this is because what is this for loop is doing? It is keep on giving one value. So what is that value is R value. So means like I should be, and what I'm trying to do, I'm trying to multiply with that fact with that I. Means like here fact is equal to n. So since I'm taking n actually, so I'm trying to return this into fact. It's like whatever is this loop is not necessary because this recursive function call itself behaves as a loop. So in the loop, what I'm trying to do, I'm trying to multiply n into something. So what is this I? So this I should be keep producing. How should I keep producing I? So I should be, while passing only, I will be doing -1. So here, how it is happening? This is happening in the incremental fashion, and this is what I'm trying to do in a reverse fashion. So I hope you understood. So only see this condition is the one condition where I'm trying to exit, because the fact is 1. Then here I'm continuing because I need to multiply. But here when it is becomes like so. See, there are two things you should be noting down. So why I'm continuing here? Because I'm trying to 1 into 2 into 3 into something that like up to n minus n. So here, but other thing is actually like when I'm trying to reduce n into n minus 1 and something, and when it is 1, so I'm not continuing, I will be exiting. So I will be exiting because this is the point I reached. So that is the reason what I have taken is this first one. If n is equal to 1, return 1. So it is as good as fact is equal to 1. Now what I'm trying to do, else means like, so in the else case, so it is something that like this location. So no need to have a for loop because this iteratively calling is actually like, so what is that factorial iteratively calling? So how it will happen actually, like, so first what happens actually, let us assume that I am trying to have a n is equal to 5. So what happens actually, the only else portion I'm looking into, So what happens, like it will come here, n is not equal to 1, so it will come to else. So what happens actually, return. So it will try to return n into, what is that n? Here n is equal to 5, so 5 into. So what is that actually I'm trying to do? I'm trying to call the fact again. So what is the value I'm passing? N minus 1. So n minus 1 means like I'm passing. So now n initially n will be 5. Now n is 4. So again the fact function will be called. So what happens actually? Yeah, now is it n is equal to 1? No. So it will come to else portion. So else what I'm trying to return n into. So means like what is that actually? I'm trying to multiply 4. So then what I'm trying to pass, I'm not passing 4 actually, n minus 1 means like I'll be passing n is equal to 3. So like that, that's 3, 2, and what happens actually, then finally, so when I'm passing the 1, so what happens when passing the 1, this function will be returning. So this will return from this. So then I will be coming here, means like this function is returned back. So means like I will be doing all these multiplication, and then function will be returned. So if you still not understood this, actually what we will do, we'll write this in a Python tutor to visually see that like how exactly it works. So because I'm trying to explain in detail, because a lot of time it will be very difficult to understand the recursive function. So let us do in a thing. So how exactly it works. So now what I'm trying to do, I'm trying to call this fact with number 5. So that is what I have done actually. So I'm trying to do with the number 5. I'm trying to call this number 5. So now let us see that like how exactly. So now what happens, I have defined. So it's like fact is defined, and this is a function, and this takes one parameter. Now I'm trying to call. This is where I'm trying to call. So this function is called. So one called, actually what is the value I passed? N is equal to 5, because n is equal to 5. So this 5 is assigned to this n. So now n is equal to 5. Now what I'm trying to do now, so it is checking if n is equal to 1. No, is not equal to 1. So this is not equal to, double equal to, equals means like comparison. This is a comparison operator. So fine. So it is not there. So it will come to the else portion. So now what happens, actually return. So return n into again. So now again I am passing another function. This is one function. So I have not ended actually. So I called another function, because another function. So again n is equal to 4. I passed a 4. So if you see here actually, then something like that, like a third, then it will see that like it is a fourth. Now the finally it will be 1. So when it comes to 1, so now I came to 1. So now the path is actually like, if you see that like how that it looks, actually it takes here. So it is fine. So it will come here. So now it is done. So means like it will return back. So it return value. So it return value means like this and this. So now 2 into 1. So this 1 is returned. So now this initially like I will come back here. So when I come back here, so you'll see that like what is the value. So then 2 is written. So 2 into 1 is equal to, so what happens actually, 2 into 1 is equal to 2. So then now again the second function also returns this 2 into n into 3. No, so it will become 6 actually. So then again this also will return. So again becomes return. So because it return here. So this 6 into this 4. So then again it will return. So this 24 into this 5. So then when finally this is the first function call. So then all function calls are done. So who is the calling out from outside? I'm calling, correct? So I will be coming out of the function. So I will come out. So if assume that like if I have another one printf here, actually I would have come out of this function and then I would have printed the value. So let us see that like I will say it is a fact is equal to, then I will print the fact. So now I would have come out of the factorial and I have executed it actually. So you would have seen that actually. Let me go fast. This is how it returns. Like finally, it will return back to the function and then next step. So because from here we called, so it will come back to the next line of this. This is how recursive function works. Any question here? Okay. So the recursive function, what you should be remembering is actually it will be called, and you should keep track of how many times it has called, and in reverse way you should be coming up. So you should remember these 2 points. So this is how the recursive function. So it is not that simple to write a recursive function. You have to practice a lot to write a recursive function. So let us see that like another example. This is a Fibonacci series. So this is a Fibonacci series. What is a Fibonacci series? If you are not known the Fibonacci series actually like, so it is initially 1, another 1. The next element will be addition of these 2, that will be 2. Next element will be addition of these 2, that will be 3. So next element will be addition of this, that will be 5. This is a Fibonacci series. So first let us see that like how to write a Fibonacci series in a iterative fashion. So how should we write? So since initial value is 1, so I'm taking first is equal to 1, and second is also 1. I'm taking the second is equal to 1, and I need how many Fibonacci series, like so how many elements. So this is first element, second element, third element, fourth element, fifth element. How many numbers you want? Fibonacci series of 5 numbers, Fibonacci series of 10 numbers, Fibonacci series of 20 numbers. I should give how many numbers we need. That is the term. So I'm trying to give the term. Term is equal to 10. Now I'm trying to give this term is equal to 10. Now how should I do actually? No, if this number of terms is only 1, so if it is only 1, what happens actually? See, only 1, so I should only print 1. If the number of terms is 2, so I should print 1 and I should print 2. So if it is number of terms is 3, then I will be adding, I will be printing this value. So 1 and 2. So that is what I'm trying to check here. If the number of term is equal to 1, this is number of terms is equal to 1. If it is 1, so then you print this one. So if number of term is second, you will print this one. So what I'm trying to do actually, I'm trying to calculate this Fibonacci. So what is this range? Range will give value from 0 to n minus 1. So this is the value. Means like, so initially like when I is equal to 0, so means like I should be printing the 1. So that is how I should be printing, correct? So when I is equal to 0, so I should be printing 1. So I is equal to 1, I should be printing 2. When I is equal to 2, means like it is not 0, not 1, then what I will be doing, I will be adding these two and I will be printing the 2. So that is what I'm trying to do. So first, if it is 0, I will be printing first. If it is 1, I will be printing second. Else, any other condition, what I will be doing, I will be adding this first term and second term and into temp, and I'm printing that temp, and I'm changing it actually. So what happens actually, like I'm skipping here. So if you see here actually again the diagram, this one, this is 1. Now what if I'm trying to do this one, actually this will become the first term and this will become the second term. So next, when you are trying to calculate the value of this, actually this will become the first term and this will become the second term. So then again, when you try to calculate this one, actually this will become the first, this will become first term, this will become second term. It's like I'll add this one. So it's like what is happening actually, first term is switching and second term also switching. How it is switching? So the recent one means like addition of first and second will become the second, and that first second will become the first. This is how I'm trying to switch. So this is what I'm trying to do. So this is a logic actually, calculating Fibonacci logic. This is a core logic. So this is how I'm trying to do in iterative fashion. This is a iterative way of calculating Fibonacci series. So can you try this actually? Anybody? So this is very common kind of questions, actually entry questions, asking you to write a Fibonacci series. Very, very simple actually. So there is nothing is there. So if you know the for loop, if you know the range, and if you know that like first term and second term, so actually this logic building is very, very essential. Like understanding that, like how should I do? So first I should be taking one element, and then second I should be taking second element. Then when I'm trying to calculate, so I should be calculating first element and second element. So then I'll be calculating the same thing. And when you're calculating the next element, you won't be using. So you'll be changing. The first element will switch point to this, and second will point to this. This is important logic. If you are not able to do, then you will be again printing the wrong thing. So this is the crux of this logic. So everywhere. So if you do, this is actual logic actually. Remaining is just like, you know that like how to iterate and other things. So any question in the Fibonacci series? Okay.
No, sir.
Okay, what we will be doing, how should we convert the Fibonacci series? Now it has a two things are there. So one thing is actually, I should be iterating up to number of terms. Number of terms I should be iterating. So we should have something like a to iterate number of terms. So what I'll be trying to do, term is equal to 10. And if term is less than that, that is invalid. So I'm trying to, else I'll be iterating these terms. So how should I start? I should start I from range. Here one I'm trying to take because that is the logic I will explain later on, into number of terms plus 1, and I'm trying to. So this is the iteration. This is fine. Now, where exactly I will be doing recursive function. So recursive function is actually like I was trying to do recursive function for to calculate changing the 1 to 2, 2 to 1. So that is what I'm trying to do that actually. Like I'm trying to change 1 to 2, 2 to 1. So it's like if I'm trying to calculate, what I'm trying to do actually, if I'm trying to calculate, so 1, 1, 2, and then it is 3. So I'm trying to calculate this value. How should I calculate this value? I should be calculating, this is nth value. So it's like I should be taking n minus 1 element. This is n minus 1 element, and I'll be taking n minus 2 element. This is previous, no? So this is a current n element. It's like I should be taking n minus 2 element. This is what I should be doing. And so it's like I should be adding this. So this for this actually, because this is because I should be establish some kind of a recursive relation. What is a recursive relation? So what we discussed in what is factorial, n into n minus 1. So that is how I should be able to establish. Is there any such kind of relationship? Like the number is whatever I'm trying to is decreasing. So that is what I should be doing in a recursive fashion. Only this kind of scenarios are suitable in a recursive kind of fashion. So in this case, we also have the such kind of recursive. It's like whenever I'm trying to find out the element n, I will be taking element -1 and element -2, and then I will be trying to add here. So then only I will be trying to get. So this is a recursive fashion, and for this I should be writing the recursive function. So how I'm writing actually, I'm trying to write recursive function n, and first we'll come to the else portion. N recursive, same thing, n-1 plus n-2, because that is how I should be doing. And if n is less than or equal to 1, I should be just returning the n. So we'll see that like how this exactly works, because this is what is the main important thing. So you should be, and this when n is equal to 1, so 1, when if it is 1, actually like there is no lesser than 1, so I'm just returning that n actually. If whatever the n values are, that is what I'm trying to return. So this is exit class. This is exit class, and this is actual recursive function call actually. So any question here? So this is iteration. So any question? So this is not that straightforward the way we did the factorial, but you should be able to figure out actually where exactly the recursive relation is there. It's like which portion of the problem statement I should be looking for recursive relationship. What is a recursive relationship? This is what. So you should be able to, and this logic building is little bit like a difficult portion. So this doesn't come in one go like just listening to me. So you should be practicing. Any problem when you are trying to divide, you should be able to figure out is there any recursiveness is there in that. Recursiveness means like this is how. So n minus, but this is recursive, correct? So I should be, see, if I know this one, I should be able to get this value. If I know this, I should be able to get this value. So something -1 or -2 to -4 for any relation, but like I should be getting next subsequent thing from the previous thing. Then only that is called recursive. So it is not like a random kind of thing. So sequential. So it is and it should be tilting towards number, some kind of a 1 or something, some exit class. Either it may be the exit class is this side, either the other side. So there should be some termination point. So if you are able to figure out actually this logic exists in that problem statement, then only you can apply recursive function very easily. And most of the times actually like it will like a difficult to do unless until you are comfortable when doing multiple recursive functions. So this is the thing you should be remembering. Any question here? So if you want to see that like how exactly this works, actually this gives us exactly same as that one. So let us see that like how exactly this executes in the visually actually. So any question here? Anybody has not understood this program? So we'll see. So now what happens actually, like let us see. So this is a definition. So it will skip actually, then it will come to here. So n terms is equal to 10. So I have defined a 10. So okay, let it be 10. So now if n terms is less than 0, no, it is not there, less than equal to 0. So it will come to the else portion. In else portion, now it will start printing the Fibonacci series. No, so I iteration. So I starts in the range. So 1 to n plus terms. So I started getting 1 value. So initially, what is the value? I value is equal to 1. So when I value is equal to 1, I am trying to call this function. So it goes this function. So what is that actually in function it does actually? It does actually like checks actually n. So now if n is equal to less than 1, it simply returns back. So I have returned back. So I have printed that 1. So next again, I am trying to do what is called I is equal to second I. So now I will be coming here. So is n is equal to 1? No, it is not the 1. So I will be coming down here. So what I'm trying to do? So now I'm trying to call n minus 1. What is n minus 1? Is 1. And n minus 2. So now n minus 1. So again, I will be calling this function. So this is how the recursion happens. So it will return 1. So I will return back actually. Now again, I will be calling recursive n minus 2, that is 0. So 0, what I'm trying to do is actually I'm trying to return the value 0. So 1 plus 0, what is actually 1 plus 0 is equal to 1. So I have done 1 plus 0, then again I'm coming back. So 1 is printed. So this is how I'm trying to print. So if you want to see that like third, so I'll be coming here. So now what happens actually, this is how it is not there, it will come here. So recursive function is called. So n minus 1 is 2. What is the value of n minus 2? That value is, so which either I will be recursively calling or I will be restating. It's like it will be again recursively calls actually. So again, it will go back and it will calculate the how it is calculated for second. So then it will, you will get it one value is equal to 1. So then again you will be calculating, so something like that. So this is how I'm trying to, it's like what is happening is actually, so it is not taking the value which is already calculated. So what is happening is actually like, so for example, if it is see this 1 and then it is 1, now I'm trying to do for 2. So what happens actually, it is trying to calculate again. This is also again run recursively. This also runs recursively, and it gets 1 by plus, and then it will do. Then when I'm trying to do 2, actually, like again, it does that, is not taking directly to value. So this again computes recursively and then gets the value. So it's like lot of what is called wrong, it's like multiple kind of calculations we are trying to do, which is not necessary. You would have directly taken the 2 because already you have calculated. But what happens actually, it is recursively again and again calculates. So every time it is again and again and it is calculate. So this is how it is happening. So is any question here? So are you able to understood? Are you able to figure out actually how exactly recursive function works? Are still not able to understand? So this is the diagram will say again. So whatever visually I have shown actually how exactly the factorial works. So whenever it is written, so this return value multiplied means like multiple function calls and one by exiting from functions, and finally final first call will be exited. So this is how the recursive function works. Any questions here? So I have done 2 programs. So if you have laptop, you would have tried this actually. So these 2 programs, recursive function. Any difficulty in understanding this problem, this program? Okay. So now one more question comes actually, like what happens if it is like somewhere else, if you are trying to not able to understand the recursive properly and you your condition is not terminating and it is going to recur infinite kind of flow. But what happens actually for such kind of scenarios, compiler or interpreter is more smarter, and it does actually up to maximum depth of recursion is 1000. Means like, so if you have seen here, so this is the depth is actually here 1 2 3 4. No, so this number of calls, how many times this functions is recursively can call, it maximum limit is actually 1000 functions calls can stay together. Means like 1000 times you means like, so this is extending up to 1000. The depth of this function calls means like one function calling another function calling another function. So this is a depth actually. This function is called by this function is calling this function. So at this moment, what is the depth actually? 1 2 3 4. So at any instant, maximum 1000 function calls will be there. So that is the, if you are going beyond that, it will turn. So in infinite kind of scenarios, so it will be infinite number of calls actually, but it compiler restricts up to only 1000. If you are having more than 1000, it will terminate. So that is the rule of a what is called this Python compiler actually. Different compiler or interpreter may be having different. So what happens actually, like you cannot have a recursive function of infinite in Python. So after sometimes it will say that like actually maximum recursion depth exceeded. Means like in Python it is defined as 1000. Means like at an instant only 1000 function calls may be there in the stack. So what is stack and all those things will be explaining in the operating system, how exactly this recursive function works, how exactly this computer stores this recursive things actually, which function is called which function called is which function. So that will be stored in some kind of a stack. So that depth maximum allowed in Python is 1000. So you cannot have. So this is all about a recursive function. Any question here? So 2 things, no? So somebody may ask, this is one question. Can we have an infinite recursion in Python? No, Python compiler doesn't allow infinite one. After 1000 kind of recursive function calls, so it will terminate the program. Terminate means like it will stop the program. So it's fine. Any question here? So this is all about the recursive function. So if you don't have a question, then we'll move on to the next advanced functions, advanced characteristics of a functions. So what all the other things actually? So let us see functions as an argument to another functions. Like so far what we understood actually. So whenever we are trying to define a function, so how it will be? So there will be function. So like something like a def and function name, and then I will be having arguments. So in colon, and then something like here, and then it will be written. So this is how it will be there. But these arguments are maybe immutable data or mutable data. That is what we discussed, correct? It is a immutable kind of a data. Then it is call by value. It will behave something similar to call by value. And if it is a mutable data, then it will behave something like call by reference. And what all those mutable data are actually list and all those things, correct? List, set, dictionary, all those things. No? So those are little things. This is what we understood. It's like arguments are data types. Now what we are discussing actually here is actually, now another thing what we'll be discussing here is actually, there may be other kind of things. Like, so we can pass the function itself as argument to the another function. It's like what we are discussing is actually, this argument is not a data type. This may also another function. So understood the difference? So this is not just generic value is a data. It is also another function. So I can pass another function call, another function to a function. Are you able to understand this? Not normal argument. How should we do that actually? Let us see that actually. So now I am trying to define one function. That function is actually square. Square is a function. It will take x, and what the square does, x into x. So it will multiply and it will return back. So this is a simple square function. So only two statement, two line. So this is how I'm trying to do. Now another function, this is applier. So here I'm passing two arguments. One is x, another is q. This q is not a normal argument. This is not an argument, this is a function. So then if it is a function, what I am trying to return q, and this x is the argument to this function. So I'm using that x and I'm calling this function. It's like this is how I'm calling, this is how. So it's like I am assuming that like first argument is not a normal argument, it is a function. And the second argument or for subsequent arguments are values or arguments for the first function what I have passed. So this is how I have defined my function. So I have just defined this function. Now what I'm trying to do in applier, I'm trying to call this function, and for this function I'm trying to pass the function name of the square. So I'm passing this function and I'm passing the value because this is expecting a value. So now what happens actually, this will call, so this will come here and this square will be called, and then it will go here and 7 into 7 49, and it will return. It is how it will be written. So it means like you can also pass a function as parameter to the another function. Any question here? Any question here? So if you want to see that like how exactly it is executed, so this is how it will be. So any question here? So what exactly it happens actually, like see, first is a square. No, so I'm qualifier whenever I'm trying to pass actually. For this, I'm trying to pass a square and 7. So this function, so what is the applier function is called. So with the square. So what happens actually in this function while returning square and 7, it will pass. So now this square function will be called. So in this 7 square function, what it will do return is 7 into 7. This is how it will be executed. So we can see that visually exactly how exactly it has executed. So first I'm trying to define the things I have defined. Indentation will be very sure. So we'll go that indentation properly. Okay, now I defined it. Now I'm coming to the applier. So what happens, like I have defined one function. So if you see here, actually square is one function, it takes x value. Applier another function, it will take two values, but one first value is not the function, not the normal value, normal argument, it is a function. So let us see that like how exactly. So now I have called applier. So I have called applier. In applier, what is there actually? So there is q. This q is pointing to this. Means like I have passed this q value, but that value is not the normal value. That is a function pointer. So see, that is how this q is pointing the square. And so there x is the value. So x is taking the value, normal value, and this q is taking the function pointer. So they're taking the pointer to the function because I have passed the function name. So that is taking a pointer to the function. So now what happens actually? I'm trying to execute. So now then whenever I call this actually, whenever I called here x is equal to, so it is calling that function. This is a functional pointer, no? So it will directly calling this one. So square is called and I passed that 7. So whatever the x value I passed. So for square, I have passed x is equal to 7. So now it will do 7 into 7 and it will return. So it is returning. So it is return means like it will come back. So now I will be returning this also. I will be returning that value. So this is how it will execute. Any question here? So if we have the laptop, so you can try out how to do. So how to do this simple program. So I'm typing here. So you try to execute the simple thing. So it is only two lines of things just to explain. It can be having a complex problem also, but to explain, I just explain using a simple thing. So any question here?
No, sir.
Okay. The next thing actually, function as a written values of another function. Means like what I'm trying to do here actually, like so function is not taking another function as a parameter, but this function will use another function to return the value. So function as a return value of another function. It's like I'm not changing the argument, I'm changing the return of a function. So return is not normal value, normal expression. That is a function call. It is something that like similar to recursive kind of thing. But like here I'm not doing recursively. So only once I'm trying to call. In recursive thing, I keep on calling the same thing. But here I'm trying to call the another function, not the same function. That is what the difference actually. So how I'm trying to define? I'm trying to define outer, and outer what I'm trying to do x, if somebody passed x, actually x into 10 I'm trying to multiply, and I'm passing defining another function, my function. So what happens, doesn't take anything, and just it is trying to take outer. So just trying to take outer, and this is outer function. So I'm trying to do take outer, means like so outer and then trying to do execute actually. So here if you see that like I'm not passing any parameter here, since I'm not got any parameter. So now when I'm trying to call here, actually, I just created an instance for this function. I have created the instance for this function. Now what I'm trying to do, I'm calling this instance functions with the parameter value. But see here, actually, it is not taking any value. But inside this will take the value. So this is how it will be executing. So if you want to see the result, so result will be, this is how the result will be there. So means like this function, it will call this function and pass this parameter. So x will take that value. So if you want to see that like how exactly this executed, so you can also see the visually how it can be. It's like how exactly it executes. So it is also 1 minute. Fine. So let me first define. So I have defined the two functions, one function, second function. Now what I'm trying to create an instance. So this function is created here, outer function is created, this is created. This is a definition actually. This is definition. So when I'm trying to execute, variable is created. So outer function variable is created. That is my function instance is created. So that is created. Now what happens actually? So, and it will be called. So now what happens in my function, I'm trying to call return outer. So this return outer I'm trying to do. So the return value is this outer function. So this is what I got actually. Return value is outer function. So now I'll come back actually return function. So now I will be getting that. So the output function is actually the return from this outer thing. So it's like this has pointed to this outer thing. Now what I'm trying to use, this one I'm trying to use with passing the value. It's like this output, whatever this time, whatever I got is actually, I got a functional pointer to the outer. It is just created a link to. So this function is just to create a link to this function. So this is what the output function has linked to the outer function. So outer function is linked actually. Now when I'm trying to call that actually, means like when I'm trying to call this function, then passing the value. So these values will be passed to the other functions, like so automatically passed to the outer function. So then outer function will execute that and I will get back to the result. So it's like this works as creating a link to the function. It is something that like I'm trying to create, like, so this is I'm just using to create a link to the function. Which function you wanted to create a link, that only function link I'm trying to create, only that function link is passed actually, and I'm using that function link and calling this function. Means like this output function is actually is alias name for this. Alias name is like some pet name. So something that like if you wanted to say that like Swati as a sat or like Satish as a sat, so assume that like assume my name is Satish, but if you wanted to call me a Sat, so then Sat is alias name. So yes, Satish is the full name. So this function does something like a just creating a alias name. So even if you call as a Sat, then I'll be like, so it is creating a link. Sat to Satish link is created by the first one, this function. And then whenever I'm using that link, means like that it is indirectly I'm calling the Satish function. This is how this works. Any question here? So any question here? So what we will do now? So we will do one more, two more things, and then we'll take 5 minutes break actually. So any questions here? Are you able to follow this? So what is the first? What is the first one? Function as an argument to function. Pardon? Hello. What is the question? Hello. Any question? Somebody is asking some question. I'm not able to hear that question. What was the question? Okay. So now, next another thing is actually function can be assigned to a variable. It's like no. So function can be assigned to variable. So far what we understood actually, to variable we can assign a data. So if you say a is equal to 10, so this is a data actually. So integer value. So a is equal to something. This is a list. This is also a data. So what we understood actually, for variable name we are trying to assign a values, correct? So now what is I'm trying to discuss now is actually we can assign, function can be assigned to a variables. Like, so how to assign a function to a variable names. Is it clear? So understood the difference between this and this. So here I'm assigning value to the variable names. But what now I'm discussing is actually how to assign a function to variable names. So is it clear? Both are different, correct? Okay. So now what I'm trying to do actually, first let me define a function. So same thing, simple function square, I'm just multiplying. So now what I'm trying to do, see here I'm just using the name. I'm not using anything. So I'm just using the name. So something similar. See, if you see here, I'm using the calling that function with the bracket, but here I'm just using the just name. So I'm just using the name. So function name. So now I'm trying to create this y is pointer to this function. So now what I will be doing, I will be using that y to call the function with certain value. This is how I'm trying to assign a function to a variable. So any question here? So very simple thing. So any question here? See, just you have to note it down. So see, if I do something like this, actually, let me do first execute this, and I will try to show that like actually if we change something, then it won't execute. So now what I'm trying to do, I'm trying to define this. I'm trying to show that actually what exactly happens there. So when, okay, definition. So when I'm saying y is equal to something, this is y is pointing, pointer will be created. Since y is pointing to the function, this y pointer is created. So next, whenever I'm trying to call y, it is indirectly calling this the square, whatever the function is pointed. So that is how. So whenever I'm calling y with 5, so that is calling square with x value is equal to 5. So it will execute and do. So what is the difference between the other one and this one? So here I'm not pausing. If I say something like this, actually this function is called, so then it will say that like you are not calling the right way. So what happens actually, it will give an error saying that like you are not passing the values. It's like, so this is what expecting, but like, so here if I do something like this, actually 5, it also gives the result. This is a proper way of calling function, but here I'm not assigning the function to variable. I'm just assigning the result of a function to the variable. So means like whenever I call the function and whatever the result comes, that result I'm assigning to y. if I do something like this. But if I do something like this, actually, I am assigning the pointer. It's like y is pointing to the function. So not the result. It's like now I can use this y to call the function. So fine. So is understood the difference between these two?
Yes, sir.
So this is another. It's like these are the advanced features of functions actually, like advanced features of functions actually. So the one more last thing is actually, so functions as part are elements of a tuple list or something. It's like we can also say instead of values in a list or a tuple, we can also have a function pointers actually. Function pointers in the list and tuple. Let us see that like how can we do. So for example, I'm creating a square, another is a cube, another is a quad. Quad means like 4 times actually to the power of 4. So I'm trying to create 3 functions, one square function, cube function, quad function. So simple functions. So what I'm trying to do, I'm trying to create a list. In the list, actually, I'm not adding a value. So I'm not adding a value. I have neither, this square is not neither a value, neither a string. So it is a function pointer. It's like it's a function pointer. So I'm storing this. What is a square? Square. What is a cube? This is a cube. So there's a quad. So I'm just creating the just a list of function names. So this list of function names. So it's like this is list of function names. Now, if I have to call this square, so what is a square? Square it at position 0. So square at position 0 means like I should be indexing the list with 0. Means like I'm accessing this. So means like I'm accessing this. This is not a value. This is not a value. That is a function. So I'm accessing this, and for this I'm passing the value. It's like this is what I'm accessing. Actually, this is not a value, but is a function. And for this function, what is the next time in bracket? What I'm passing is actually how many arguments it expects. So that arguments I'm passing. This is how I'm trying to create a list of functions or tuple, what is called a tuple or list of functions. Like here, I'm trying to create a list of functions. So this also possible to do. So if you want to see that, like, so if you wanted to use something else actually, instead of this actually square, if I want to call the cube, so I should be accessing the cube. So cube is this is index 0, this is index 1. So I will be calling the cube, and the result I will be getting cube. So if you want to call the quad, so I will be indexing the quad. So that is called, I should be, what is the index 2. So this is how I'm trying to call that actually. So if it has a 2 parameter, then you should pass in 2 parameter. So this is how any number of parameters. But first is actually you should be accessing that value. So means like this is how I should be accessing. And next is actually, this is actually something that like parameters. So something like if you have to say how exactly it is happening is actually, so something like this you can say. So for example, if I'm saying that list actually, in list I have square. So I have a square. So something that like square and something cube and something. Now what I'm trying to do when I'm saying L0 and when I'm saying L0 and I'm trying to pass this value, parameter is 5. So it is something that like this L0 is replaced by square. It is something that like a square and I'm passing 5. Because this L0 is accessing this first element, correct? So then I will be replacing that and then it will become a function. And then this is a calling the parameter to that. This is how it will happen. This kind of flexibility Python provides. So fine. Any question? So if you wanted to create a tuple of that, you can also create a tuple of that. So you can also create a tuple and with the elements. So if you want to create a dictionary of that, so you can also create dictionary. So this is a keyword, this is a keyword, and this is a value. This value is function name. This is a keyword. You can create any keyword. It's up to you. This is a value. The value should be function name. This is a keyword, so value. So I have created a list. So how should I access the dictionary? So I should be using the keyword. So that keyword, and then again I'm passing the value. So this is how I can do. So if you want to access a cube, so you should be passing here cube because the dictionary is accessed using something. So this is how it can be done. Any question? So this is what is actually you function as element of a iteration object or element of a tuple or list or something dictionary. These are collection kind of objects. So you can have that done. So any question? So if you want to do something like a set also, you can create something from set. So I'm creating a set with the bracket and with the value. So but say set we cannot access using index, correct? So set is unordered thing. So you cannot index. So you should be using the loop, for loop, to iterate the value. So means like I will take first in square, then next it will take cube, next it will take a chord, and then I will be using I and then passing the parameters. So this is how I should be executing. If you are creating a function of set of functions. So if you are creating a set of functions, because set cannot be accessed like this. So dictionary can be accessed using the key, tuple can be accessed using index, square can be accessed in the index, but set cannot be done. So I am iterating using for loop. So any of these data sets you can use to create. So this ends here. So we'll take 5 minutes break and then we'll discuss further more advanced functions actually. So any questions here so far? Anybody's any question? Or if you want to see that like how exactly it is executed, we'll show here actually. Like if you wanted to see visually, like so it will be something the same, multiple pointers will be created. So but so let me do that actually. It is just like a pointer thing. So visually, if you want to see, so you can see that how exactly it is executing. So any questions? Anybody has any questions? Anybody has any questions? See, I'm first creating the things. Okay, so see when I create a list actually, the list is created and list will have see pointers like so. One is this is pointing this function, this is pointing this is pointing. So only pointers are created. So when I'm accessing this two, so it's like I'm accessing this two. So this pointer. So I'm passing value means like I'm passing value to this function actually. This is how it is happening. So I'm accessing that function and passing that value. So this is how it will execute. Fine. Okay, so we'll take 5 minutes back, then we'll continue. Shall we start now? Hello.
Yes, sir.
Okay. So what else we looked into actually, like we looked into different ways of functions calling and features of the Python functions actually. Some of things may not be there in other programming language, but it is all about Python only. So this may not work with other programming language, but be careful. Like so, when you don't think that like whatever is working in Python also works in other programming language. Python is more flexible, provides more advanced features. May not be other programming language uses features actually, especially like so these kind of things actually. The another thing is called anonymous function. What is meant by, why we are saying that like anonymous function? So let us see that like this is again this function. So this is simple kind of functions, correct? So def square and x. So to do just x into x actually, do we need a proper way of defining a function and proper way of calling a function, all those things? Because when you define a function, what happens actually? The definition will be created and the memory for that functions and everything will be stored, all those things. And function calling is actually like, so if you define here function and you are calling, then you will be calling that function with the arguments and it will execute and it will return back. So whole lot of like lot of things. Like so if you understand the assembly programming, so you see actually to convert this function into assembly, it will create a lot of instructions it needs and lot of jump from one location to another location, because like this instruction to jump to this location and after completion it will come back to this instruction. Is like, so for example, if I have defined functions here and I'm calling here, so while executing this actually you'll be jumping here and you'll be executing this and then again you're jumping back next statement, and this is how all things will happen. So if you are not doing a lot of things in the function, like lot of operations or statements or lot of calculations in the function, if just using for just see what the way we know square means like x into x, so why we need this kind of a proper way of defining a function? Can we use something simpler than that? Actually, for that purpose they have defined something called a lambda function. So lambda function is a simple function, anonymous kind of functions. It doesn't need this or these all these things actually. So lambda function is simple and anonymous things for normal kind of operation. How is the syntax? Syntax is start with the keyword lambda and the arguments. Arguments means like the way same the arguments for a function, arguments for the Lambda functions, and then the colon and the expression. So that expression is like expression includes all those things, correct? Every expression can be said as part of expression. This is a syntax. This is syntax of Lambda function. Let us see that like one Lambda function. So same thing. So for the same way what we are trying to do, same thing. Let us see like lambda is equal to lambda, this is lambda and x. So it will take parameter x, and in the colon, so I'm trying to do x into 2, or like you can say x into x, both are fine. So x into 2, both are same, x into x or x square. So here I'm doing x into 2, or doubling I'm trying to do. But if you want to do square of that, then x to the power of x. So here I'm just multiplying with the 2. Anything you can do. So if you wanted to do lambda function for the square, then it will be x into x. But here what I'm trying to do, this function is whatever the value you are giving, that value I'm trying to multiply with, doubling that actually. So this is a function. This is the lambda function, and the result I am trying to assign to something called a double. Much like what is this double is actually, this is the this whole thing is assigned to something called a double. So now I will be using this double to call this lambda function. So this is a lambda function, and this function I'm assigning to something called a double. So it is something similar to what we used to do. So what I used to say is something like when I say y is equal to square. So what I'm trying to do actually, I am trying to assign this function to the parameter y, and then I will be using this parameter y to call the function, correct? So something similar to that I'm trying to do here. So this is a lambda function, and this is one line kind of function, and I am assigning to double. So now I will be using this double to call this. So what happens actually, I'm passing this double x. So why I'm passing 5? So this value will be assigned to this x actually. This will be assigned to this x. Now what happens actually, okay, now this function is called and x assigned 5. Then I will be coming here and I will be executing. What I'm trying to do, 5 into 2. So the 5 into 2 is actually is what is the thing. So and that is the result. So that is the result, and it will print that result. So what is that? 5 into 2 is equal to 10. So if you want to give something like around 10, it will give 20. So this is how the lambda function. This is a basic simple lambda function. So it is something similar to this. So in traditional way, if you have to define instead of using lambda, so without using lambda, if you want to do define a traditional function, so then it will be def and double and takes x and return is equal to x into x. So this is how I'm trying to do that. So this and this is same. This and this is same. And when you are trying to call that, I'm trying to call that like so. Any questions here? So lambda function, why we should be calling that? Any question here?
No, sir.
Okay, so let us see another function. So what I'm trying to do here, I'm passing 2 parameters. So I'm passing 2 parameters. One parameter is x, another parameter is y. So what I'm trying to do, I'm trying to create this is expression. What is the expression? 2 into x plus y. This is what I'm trying to do. So now this f is a function pointer. So this is a function pointer. It is a lambda function pointer. So if you want to call this one, so you should be calling with the values. So how should I pass actually? F into, then I will be passing those values. What is that actually? 3 will be assigned to x, 4 is assigned to y. So this is how I'm trying to execute. So if you wanted to change something, you can change. So if you want to say that like it is 8, so 8 into 2 is 16 plus 4 is equal to 20. So this is the result we'll be getting. Any question? So this example is with 1 variable, this example with the 2 variable. Any questions?
No, sir.
Okay, so instead of like assigning into one function and then calling that function, I just wanted to pass the parameter right away and get the result. So I don't interested in getting a function pointer. I just interested in getting the value. So then you should be doing something like this. So this is a function. This is a function, and this is a parameter I'm passing to this function. So this is within the bracket. You see that like within the bracket, and this is a value. So if he's asking one value, I'm passing one value. If it's asking 2 values, I should be passing 2 values. So then what happens actually, this 100 will be passed here, 100 will be assigned to this x, and now what it will do, x into x, it will calculate, and the value will be returned, and that value will be assigned to v. So here, this is, see, this is a function pointer because I'm not doing in the bracket. So this is a function pointer, but this is the result I am trying to put into value v. So this you should be remembering. So here itself I'm trying to call this function. So this is something that like within the bracket. So means like this is a function. So this function and I'm calling this function with this bracket. So the result is assigned. So this is different and this is different. So this is the function pointer, this is a value written by the function. So the lambda is always lambda. So if you misspell actually, then it doesn't recognize. So this is not recognizing. So this is lambda. So this is a keyword. So it should be proper. And if you go for actually, like even if you remove this one, actually it doesn't recognize. It will give an error. So all these syntax should be very clear. So name and parameters, then colon, and then expression. So that should be there. And if you are doing in the bracket and then passing this one, actually you are calling and the result is there. So these things you should be remembering. And if I said no, so if two parameters, so if I'm passing the two parameters, I should be passing two parameters. So first one I have showed with the one parameter. The second one I'm trying to show the two parameters. So I'm passing and I'm getting the result. So any question here?
No, sir.
So this is a lambda function. So this is a lambda function. So so now not only the lambda function, Python provides multiple other kind of functions, like multiple other kind of functions, multiple kind of other kind of advanced kind of features in the Python. So one by one we'll see. So we'll see something called a map. So there is one more feature or function is actually this called map. What this map does actually, name itself says no something it will map. So map is something it will map. So let us see that like what exactly map does. So for example, if I'm trying to create this one, so if I take this case actually, so what I'm trying to do is actually this is a list. This is a list of numbers. I'm trying to define the list of numbers, and now I'm trying to define a function. This is a proper function. So def square, and it will take some parameters. What is that? It will take a parameter called number. This numbers, this is different and this is different. This is a number. So this it will parameter as a number, and it will return number into number. Means like squaring that. Whatever the number you pass, it will square and return. So what I have defined a list actually. Now I have defined a what is called a function. So what I'm trying to do, I'm trying to create a map function. This map function will take two parameters. What is this one and that is the first one is a function. It will take one function. It can be normal function, it can be lambda function, whatever it may be. But first one will take a function. Either it can be null function. So it will take a first function. And the second one is will take is actually numbers. Numbers like is a literals. Literals means like it may be list, it may be tuple, it may be all those things, literals actually. The second thing is a literals. Means like it will have number of items actually. This is a collection kind of, or it can be one also. So this is how. So what happens actually, map in the bracket, I am passing one parameter and one list actually. So now what I'm trying to do, I'm trying to create a square number iterator. Means like I'm trying to create another variable that is called of iterator. So what I'm trying to do, I'm trying to create a list of that, and I'm trying to print. So what exactly happens actually? So whenever you do something like this actually, so it is something similar to this. So for example, if I have defined a square function, and square function, I have to pass value and it will do x into x, correct? So now I have a list of elements. So assume that like 1, 2, 3, 4, 5, so something. Now what I'm trying to do, I'm saying the map of this square, and then I'm trying to pass this list actually. This is a list I'm trying to put. So what happens actually, this map will do, first it will call this function with one parameter, that is first value. So it's like it will pass first one and it will get the result. The result is what actually? Result is square, means like square of 1 is 1. So next what happens, this function again called with the second value. So what is the value here? The second is 2. So what is the result is 2. So now it get the result. So again it will call this map, it will call this function with the third value. So that is third here. So that result is 6. So again it will call that function. So till number of elements exist in this list or whatever it is object. So it's like it is every time, instead of you calling one by one, you are using a map function, and map function will do, okay, this is a function, you will be calling with multiple values one by one. And finally what I'm trying to do, whatever the result comes, that result I am trying to create a list of a result I'm trying to create. and then I'm trying to print that list actually. This is how. So the map function is actually, intention is actually whatever the function you are passing and whatever the iterators or iterable objects you are passing or like a data type you are passing. So it will call that function multiple times with 111111 value. So one value, first it will call with one first value, second it will second value, third value, and result will be there. And then finally that result has to be stored in some format, either in the list format or any format. Now I'm trying to create in this format and I'm trying to print. So this is how it will work. So if you want to see that actually like this, how exactly this looks like actually. So this is visually, you can see this actually, like this will be one by one with calling. It's like it will show exactly like how exactly this call execution happens. So one by one by one by one. So now first I'm trying to create a list. So list is created. So this is a list, and if C actually list, and if for 2, this is index, this is value. So list is created. Now I have defined a what is called function. So I have defined a function. So function is created instance, and that it will take an argument. All these things is done. Now I'm trying to create this map function. So I have created the map function. So now I created a map function. What is this map function? This map function. So square iteration, I've created a map instance. So now I created. Now what I'm trying to create a list. So list of this one. So till when I'm do this, actually only instance is created. When I created a list, then it will start executing. So now what happens actually? First square is called with what is the first element? First element is 2. So means like square function is called. This is say square function is called with the value 2. So now again this will be executed. So then next it will come back to the map function. So what is the value it is passed? So next value is 4 and passing to the square function. So one by one. So next till what actually? So till the last element. Last element is 10. So number 6 is called now. So now number 8 is done. Now finally, so I will be coming with a 10. So when I do the 10, so return 10 into 10 is equal to 100. So now it is done. Now I will come back. So I will come back and the list is created. So result list will be created. So what is the 4, all this thing, and now I'm trying to print. This is how map first. Map is actually whatever the function you are providing. The first argument is a function, and that function will be called multiple times. How many times? Depending on how many elements are there in the iterable objects. So and then result will be stored, whatever the format you are trying to do. So but when if you are saying list, it will be created into list. If it is saying set, it will be created into set. So is it understood? Any question here? So the parameters for the function, parameter for map function is first is function, second is iterable, and then you should be using any list and set. So let us do another one. So calculate a square. So this is another one. So we can do that also. So what I'm changing here. So here I'm trying to convert into list. Here I'm trying to put into set. So that is the only difference. Rest remaining is same. So if you wanted to, instead of using the normal function, you can also use the lambda function. So lambda function. So this will pass on one parameter for lambda functions. So this also work exactly same. So exactly same, and it will create and it will give the result. And result is stored in set. So it's fine. So anything like, so you can create any kind of things like, so you can use normal function, you can do so lambda function, any of those functions can be possible. Any question here? Okay. So now, so far what we looked at actually one function, one thing one. What if it has two lists actually? So now voice is not clear. Hello, my voice is not audible. Hello. Shall I repeat again? Understood or not understood?
Once repeat.
Okay. So, okay, what I'm trying to say is whenever I'm saying that like a map is a function, so it will take two arguments. One argument is the first argument is a function. So function is the first argument, and second argument is a list of the elements. Means like maybe it may be list, it may be collection, it may be set, whatever it may be, the number of elements actually. So what exactly this map function does? So whatever the function you are passing and whatever the iteration it is passing. Like for example, in this map function, I'm trying to pass a square function. So squaring is a number of something. So now I'm trying to pass a list of elements. So what happens actually? First time it will call the square function with the first element of a list with value 2. Then second, it will call again the function with the second parameter 4. Third, again it will call the function with the value 6. So again it will call with another like 8. It's like one by one by one by till all elements are done with the second parameters. So this function will call, and all these return values will be stored, whichever the format you say. If you say set, so it will be stored in the set. So if you see here actually the result, so what I'm trying to do, I'm trying to create a list here, and I'm trying to define, because it needs one function and one iterables. So I'm trying to create, it can be anything. It can be list, it can be any other things. I'm just creating a list. So now one function. So now what is necessary for me? I should be passing the one function, one iterables, and then this will be assigned to some kind of variable. And what I'm trying to do, this one, whatever the result comes, that result has to be stored into the list. So list keyword I'm using means like that result will be stored, and this is where it will be stored. And I'm trying to print that actually. So if you see here actually, so I'm not calling this one by one by one. It is something similar to something like this actually. If same thing, if you have to do, so no, so it's like same thing in the normal way. If I have to do, so I should be doing something like this. Let me show that actually. So this one, instead of this one, what I will be doing is actually, I will be doing something like that. Like so, this is empty list. So I'm trying to create an empty list. Now for I in range of, in the range of length of numbers. So numbers. So now, or else instead of this way, I directly will give that numbers actually. So now I will be giving in numbers. Now what I will be doing? So for everything I will be trying to add. So what I will be doing? So L dot append into the list. I'm trying to, what I'm trying to append, I'm calling this square. I'm trying to call the square with the value I. This is like I am calling every one value one times. So in for loop. So now I am trying to print this one. This both will be exactly same. Instead of doing all these things in the regular way, so creating a for loop and calling individually one function one times with one value. So this entire thing will be this, whatever I'm trying to do, this statement will be done by using a map function and storing the result into a list, and I'm printing the list. So this is what is done. It's like every time what I'm trying to here, I'm manually doing. So calling one function with one value, calling one function with one value, so that is all done by the map function. Calling this function with one value, calling this function with next value, calling this function with another value. So this is how it will be done. This is called map. So is it understood? Now voice is clear?
Yes, sir.
Okay. So no need be that is normal function. You can also have something like a lambda function. No, not necessary. It should be normal function. It can be lambda function also. And no need to store into only the list. You can store into set also. Result can be stored into set also. So there is no such things you can do. Store into list. So all these possible things are there. So far what we have discussed actually, one function, one value thing. But what if I have one function with two arguments? So if it is like, see, what is actually like I'm trying to take lambda function, it will take two arguments. Then what I'll be doing? First is a function. This is a function till this extent is function. Then this function is taking one argument, then one list. If it's taking two argument, it will be two list. So since this function taking two arguments, I'm passing two list. So what happens actually? First, this function will be called with one element from here, one element from here. Means like, for example, this function will be called with first with 4 and 5. Then again, second time, this function will be called with value 5 and 6. Again, this function will be called with value 6 and 7. So what exactly this function does? It will add. It's like, oh, first when I pass 4 and 5, it will add 4 plus 5 is 9. So it will add and store result. However, it will store in the list. So 9 is added to the list. So then what will happen? 5 plus 6, because I am passing one element here, one element here. So 5 plus 6 is 11. So that will be added to the list. So 11. So again, what I'm trying to do? I'm trying to do 6 and 7. So it will be added. So it will pass 6 and 7 will pass. and it will addition, and that will be added to list. This is how it will work. It's like you can have function with one variable, one argument, function with multiple arguments. So this also supports. Any question here?
Sir, why we are putting comma
Okay, this comma, or this comma.
with
There are
n1 comma n2?
okay, this is n1 comma n2 is two arguments. The lambda function we discussed, correct? So this lambda function will take two arguments, and then the colon. Before the colon, after the lambda, before the colon, how many elements are there? Those are number of arguments. So it will take one argument, it will take second argument, lambda function. That we discussed here only, no? The lambda function, how to define before we jump into. So lambda function with one argument, lambda function with two arguments. So this is the lambda function with one argument, two arguments. Like this is the lambda function with two arguments, x comma y. Correct. So now, if you go back here, so this is a lambda function. Till this is a lambda function. Then since this lambda function takes two arguments, so I am passing two list. So before this, if you say this lambda function, this is a lambda function, correct? This is a lambda function. So what it takes one argument. So one list. Understood?
Yes, sir.
So you can define even normal function also, 80 things. Like what I'm trying to say here actually. So this function is something that like, so if you say map, when you say map, first thing is function name. So now if this function takes one argument, then one list. If it takes two arguments, then two list. If it takes three arguments, three list. If it takes four arguments, four list. So what happens? So when this function is called, so this function is called with one element from here, one element from here, one element from here, one element from here. Next again, it will call function with another argument from here, one from here. This is how it will be calling. That is called map function. So function will be called with next values. Is it clear? So if you, okay, let me do that. Okay. Let me just visually, let me show you that. That will be better. I think I have showed one lambda. That is the reason I'm not showing it actually. So created. So map is created. So now list I'm trying to create. So first I'm passing that lambda function argument 4 and 5. So next, this is the lambda function symbol. So this is next. So now if I do next, actually again that is returned, and now another lambda function called with value 5 and 6. So that is returned. That is returned. It will return 11. So when 11 is added to the list actually. Now again I'm calling this lambda function calling 6 and 7. So now I'm adding that. So it will be written, and then finally it will return come back, and that will be stored into a list. So that list is 9, 11, and 13. That is what I've printed. Any question? So understood how the map function works? Understood? Yes or no? Hello?
Sir, repeat once again.
Okay. See what I'm trying to do. I'm trying to create one list. I'm trying to create another list. Fine. So I'm trying to call a map function. What I'm trying to call? I'm trying to call with a function. What is this function? This is a lambda function. And what is the number of parameter to take? It will take one parameter, second parameter. And after taking this parameter, what it will do? It will add n1 plus n2. and that is the result you show. This is a lambda function. So if you understood lambda function, this is how the lambda function works. Now I'm calling this lambda function, and since this lambda function takes two parameters, I'm passing two lists. This is one list, this is second list. So now then what I'm trying, this result, whatever the result is, that result I'm trying to store into the list using list keyword, and that result I'm trying to print. Is it understood, this one? Okay, understood or not?
Yes, sir.
Now how it will work? So now first I created list. This is how I created a list. Second, visually, this is how I created a second list. Now I created a map. So map. Now I'm trying to do instance is created. Map instance is created. Now I'm trying to execute that. So one by one. So how it will execute? First, it will call the lambda function. So the lambda function is, so here is the lambda, but since lambda function notion was this is a lambda. So if you see here, actually there is lambda. So this function, it's like lambda function is called with what? It needs two parameters, n1 and n2. So n1 and n2. What is the value I passed? Actually, I passed 4 and 5. What is the 4 and 5? First element of one list, first element of second list. So first list, second list. So first element of first list, first element of second list. So what happens actually in the lambda? What it will do? 4 plus 5. 4 plus 5 is 9. So it will calculate. So it will calculate that, and what is the value? Result is 9. 9 will be returned. Now return means like, since I'm storing that result into a list, so it will be added to the list. So next, another time function is called. What is that? Lambda function is again called. So what is the values it's passed actually? So second element of the first list, second element of the second list. So 5 and 6. So now what exactly lambda does? So 5, I got 5 and I got 6. So I will be adding that. So 5 plus 6 is equal to 5 plus 6 is 11. So this is the function returns. So return what? So return I stored into a list. So next, because since it not ended actually, because one more element is there. So again, this lambda function is called. Now this time, the third element of the first list, third element of the second list. So n is equal to 6, n2 is equal to 7. So what lambda does? N1 plus n2. So it's like 6 plus 7 is 13. So it will calculate and the return 13 will be there. So now it will add third. After that, like there is no further element is there. So it will come out of that thing and print the result. So this is how the map function works. Map function is like, it will call that function with the multiple parameters one by one. It is something similar to that what I have showed here, no? So similar to something like this. Manually, if you are trying to call that function. So this is how it is a manually. So it's like for loop, and I'm trying to call that function multiple times with the different values. So this is the manually I'm trying to do. This all activity is done by one function. That function is map function. Is it understood?
Yes, sir.
So this is a map function, and variations of map functions also there. Like I explained with map function with one function, one variable. Now I'm saying one function with two variables because that function needs two variables. Then other version also is there. So I will cover this actually, and I will stop here because I think it is more complex. These concepts are more complex. That's the reason you may be taking some time. So another thing is actually like instead of passing the one value, actually I'm trying to do something like a string. String is actually, what is a string? String consists of multiple characters. So no need to say that like string is list. So I'm passing the string. So map, and I'm passing the list. So list is what actually? List is the keyword. Whatever for list, whatever the value you are passing, that will create a list. So it's like, so if you pass something to the list. So for example, if I have a string, so something like S, I'm trying to say S is a string. And if that has a Satish actually is a name I'm stored, and now I'm trying to create. So something like a L I'm trying to create, and using the keyword list. If I do list actually, then pass this S. So what exactly happens actually? It will create a list of characters. How it will do? First character is one element, second character is another element, third character is another element. SAT SE actually. So SAT. Second character, third character, another two E actually. Then so much like whatever, how many characters are there, and yes. So this is how it will create a list of element. So this keyword will, this list is a converting this, it will converting string to a list. So how it will convert? It will take each individual one element as a element of a list. So this is what it does. So what I'm trying to do here is actually, I'm calling a map function, and for that map function, I'm saying that like whatever the parameter you are passing to that function, it will convert that function, that value into a list. So it's like this list will create a list actually, and this is the parameter. This parameter is actually the list of strings. So list of strings means like what happens. First time I will be calling this function list with the value sat. Second time I will be calling function list actually with the value bat. Third time I will be calling list with value cat. Last time I will be calling list with value mat. So what happens actually when I'm calling list with the sat, so it will create a list of characters. What is the characters of sat? Yes, AT means like it will create one list of characters. And second time when I call list with the bat, so it will create a list of each individual character. What is the individual character? BAT. Then third time when I call that list with the value cat, so it will create one individual variables. Means like so CAT. So this is a list actually. So it will create. Means like every time whenever we are calling this list with one value, one string, so it will create a list of those individual characters. That is what I explained here. Correct. I just explained with one example. So whenever I call list with one string, so it will create a list of individual element. So this is how means like so here I'm trying to call this multiple times. One with sat, another with bat, another with cat, another with mat. So many lists will be created, and finally this list of list will be created because of this final list. So this is like what I'm trying to say is actually like lot of things are done in single line. So lot of things is done in single line. So if you wanted to do the same thing using the normal kind of things, then you should be doing a lot of things. Like so same kind of things without using map if you are to do. So then you should be writing multiple lines of code. So for example, this is how I'm trying to do. So now what I will be doing, I'll be trying to create a test list, dummy test list actually. Dummy test list is something like that I'm trying to create. Now I'm trying to do what actually for I in L I'll be getting. Then what I'll be doing in test I'll be appending. What is that actually I'm trying to append actually? This list function I'm called with the value I. So this is how, and then I'll be printing. So this is how I'll be writing in a traditional way without using what is called map. So both will be doing the same thing. So this is what is done by. So both will be done the same thing. It's like this whole thing. So all these statements are all reduced by one single statement. So one is a list. Means like finally it will be stored result into list. And this is a map function. Means like it will calling function, that function with individual values multiple times. How many times? How many elements are there in the this L list actually? This is how this is a traditional way, and this is done by using the map function. The functionality of this map function and this code is same. So this is how the map function works. Any question?
No, sir.
So fine. So I explained, see again, so now I will end here because it's a lot of advanced concepts. Maybe it will bounce over your head. So I will reiterate actually. So one is the map. So what are the things we discussed today is actually, first thing what we discussed actually, the recursive function. What is meant by recursive function, and how we will be writing a recursive function for factorial and something. So you should practice that. So recursive function we discussed first, and then we discussed about if we do infinite kind of recursion, what will happen, that we discussed. Then what we discussed actually, like how to pass a function as a parameter to another function as an argument to another function. How should do that we will discuss. And how should we make a return of a function as a function. So function as a return value of another function, so that we discuss actually. Then we discuss actually how to assign a function to a variable. Assign a function to a variable means like instead of assigning a value, I'm assigning a function to a variable, that we discussed. Then we discussed actually how to create a function list of functions, set of functions, all those things, and how to call them actually, that we discussed. So these are the advanced kind of things. Then we discussed what is called lambda function. What is a lambda function, why we should be doing. So lambda function is actually, instead of writing something like a traditional way, we should be writing in a single line. So then we created a lambda function to do simple work with one variable. Then we created a lambda function with the two variables, that we all done. Then we started discussing about some more advanced functions of Python. One is called map. So only map we discussed. So other things we'll discuss in the next sessions actually. I thought I should be discussing today only, but I think is too much. So map function, what the map function does, how the map function works. The map function is something similar to something like a for loop. It's like instead of me individually calling a function with one value, I'm using map, and map will do call that function with the individual value and calculate and store the result into appropriate format. So if you are saying that like store result into list here, it will store into list. If you are saying store result into set here, then it will store result into set. So this is how the map function does. So we discussed about the map function with one variable, function with one variable. We also discussed with the map function with two variables. We also discussed the map function with a list string, how it will behave with a string. So how can we do that? So this is all about map function. And next class we'll be discussing about filter. See, one more thing you remember, whatever I'm trying to say, this lambda function and this functional methodologies, map functions, only 10 to 15% of the people who claim they are Python programmer can able to do. Remaining 80-90% people doesn't know how to do these programs. And this is advanced. That is why I'm saying it's advanced. And if you are able to write this, then you are in that category. You are not in the bottom 80%, you are top 20% category. So these are things you should be practicing. So they will ask you about these functions, actually, how to use a map function, how to use a lambda, create a lambda function. All these are like things are something like calling multiple functions, like list of functions, all those things. These are advanced kind of features. You should be practicing it. So I said no. So basic Python is already done. I have completed the basic Python. Now what I'm discussing is the advanced Python. So and in advanced functions in Python also. So these things are there. Like what I was trying is actually like after these things, after this map, filter, zip, and reduce. So some more things I'll be discussing, and then advanced functions also done actually. So after advanced functions also done, then we will switch to another things like remaining, like so another apart from this, like exceptional handling, file handling, thread and multi-threading, socket programming, and regular expressions. These things I will be covering in the live sessions. And remaining so many other things also there, so many other advanced features also there. But I won't be boring with advanced things. I will be creating one video for one topic actually. So you can, because these things are rarely asked. Up to this will be a lot of things actually. Beyond this, if you wanted to be more curious about to know more and more and deeper kind of Python, you can also start watching these videos. So these I will be creating multiple videos actually. So you can keep watching. So one topic, one video will be keep on doing. But as per the syllabus kind of things, like I have completed the basic Python, and if I completed this also, I have completed advanced Python also. Then we will be switching to the statistics and mathematics. So we'll be conducting, we'll be giving a lot of programming assignments. We'll be conducting quiz, and we'll be taking exams on this Python. So I'm just giving some time so that like you should be practicing. Some people has exams, some other people also exams. So one after another person are having exams. So I'm just giving some time to practice. Maybe in the month of May, I will take exam on Python. Till that time, I will be giving a lot of assignments to you people. Any questions? So you should be able to practice. Like, so I will be giving a lot of programs using this map, lambda, all these things, advanced things, and apart from the basic things also. So we'll do that actually. And still, if you are facing the issue, then I'm trying to create another series how to, because most, see, now you know the language things, programming, how to write a program and the syntax of the Python programming. But now you may be facing another issue, is that is about how to create a logic. So logic creation is like a difficult thing. So the logical thinking is a little bit difficult thing. So to do that, actually, I'm trying to take another one video series session. So how to construct a logic for a problem statement. So one by one, I will be trying to like I will try to how to create a logic for Fibonacci series, how to create a logic for, it's like not the programming actually, but logic. Logic behind is a little bit difficult, and that only comes if you practice. If you are not practicing, the logic won't come. So if you just listen and go, listen and go, listen and go. So you understand syntax, you will understand the code. You will understand the somebody has written the code. So if I write something code, you will be able to understand and you will be able to see what would be the output.